Hi synth lovers. Welcome back to my channel. I hope you are doing well. This video is part of a series of videos in which I am designing and building my own DIY modular synth from scratch. All documentation from this project, including schematics and Gerber files, will become available on my Patreon as we progress. If you like this kind of content, consider subscribing and hit the like button. Leave a comment if you have questions or suggestions, or if you just want to say hello. While I am waiting for the parts and PCBs for my VCO, I will investigate some other modules. In this episode, we will explore a simple mixer. I will create the schematic and design the PCB and front panel. The simplest mixer is a resistor network, as shown here. We can attenuate the input voltage by the potentiometer. However, the circuit will act as a voltage divider. When the slider of the potentiometer of one channel is moved to the ground position, the input signal of the other channel will be divided by 2. On the other hand, when there is no signal on one channel while the slider is in the top position, the input signal will be attenuated by 33%. Practically, this means that we can never get the true sum of both channels on our output. How can we fix that? By adding an op-amp, of course. In this example, I also added a third input channel. The signal of this channel is not mixed in yet. We can see that the output signal is almost the sum of the two input signals. So, this is an improvement. By the way, all input signals in this example have the same frequency and are perfectly in phase with each other. When we mix in the third signal, we expect the output to go to almost 15 volts. However, we see something strange happening here. The output signal is clipping to about 12 volts. Why is that? That is the normal behavior of an op-amp. The output signal of an op-amp can never be higher than the power supply that feeds it. In our case, this is plus and minus 12 volts. There is not much we can do about this. For me, personally, I don't see it as a problem. Let's also buffer the inputs, so that we don't put too much load on the input providers. I will also add a potentiometer as a master level control. This will allow me to lower the level of the summed inputs, without having to set the input potentiometers. And here we have the completed schematic. I did not use any capacitors to get rid of a potential DC bias. This allows us to use the mixer for audio and control voltage signals. The potentiometers are linear. For audio, it is better if they are logarithmic. I will try it out. If it bothers me too much, I will make a mixer, specifically for audio, later. If you can suggest any improvements, please leave a comment. It can benefit every synth DIY person. In the next part, I will show the design of the PCB in a time lapse. As usual, I already created the edge cuts for the PCB and front panel. I also decided on the position of the potentiometers and jacks. These will be mapped on the blue grid lines. This is the final PCB. And this is the final front panel design. I know the front panel could be better, and it is something I want to improve in future designs. That is it for this episode. Next time I will pick up an easy module, the multiple. Thanks for watching. If you like this kind of content, consider subscribing and hit the like button. Leave a comment if you have questions or suggestions. Or, if you just want to say hello. You can support me by becoming a patron and follow me on social media. You can find the links to my Patreon and social media in the description. Have a nice day and see you next time.